7.6, change base rule of logarithm. Okay, let's start with easy examples. And now we are all experts of evaluating log. And let's try this. Evaluate log base 8 of 2. How much is it? Log base 8 of 2. But don't get confused. Log base 2 of 8 is easy. This is what? What exponent of base 2 becomes 8? So it's 3, right? So compare to this. What we currently have is this. What is it? Log base 8 of 2. Then I don't know. Then let's try it. Then when we evaluate, we do this. We set this one with x, right? Then we do what? We convert it to exponential expression. So the base is 8. So then now we have log base 8 of 2 equals to x. And then if I convert this equation into exponential equation, the base 8 will get x as the exponent, and this is what? 2. Then I guess some of you guys already get this format, but let's do step by step. So in order to find the exponent, and then I have to match the base. So 8 is 2 cubed. So now let's rewrite it. It's 2 cubed, right? Then it's raised to power of x. Now I simply rewrote 8 into cubed, and then the other side is 2 copy down. Then now using the power rule, this is 2 to the power of 3x, then it's 2. Then the right side of the equal sign 2 has invisible 1 as the exponent. So now we can have 3x should be matched to 1. How? 2 base here, 2 base here. Then in order to satisfy the equation, we can assume 3x should be equal to 1. Then now we have simple equation, 3x is equal to 1. Then this means x is 1/3. Then conclusion, now we have log base 8 of 2 is not 3, what? 1/3. Good? Okay. Then this could be very helpful to do some of the practice problem, okay? Then now, another example. Okay, so then let's call it example number 1. Oh, let's not do, okay. So number 1 was that, okay? Then number 2, now we have this log base 5 of 14. Okay, then if we are supposed to evaluate log base 5 of 14, and we can go through exactly same steps that we did here. So let's rewrite it here, log base 5 of 14, and then I set it up with x. Then I will convert it. So now 5 is the base, and this x becomes exponent, and then 14 goes the other side, and then it's 14. So compared to earlier example, we were able to match the base so that we can directly compare the exponents from the both sides, and then it was clearly easy. But now this is a little bit of a problem because it might not be simple for us to match the base with 5 and 14. They are not really good ingredients, as you see. Then, very similar to the basics of dealing with manipulating equations, we will do something to both sides. So manipulation to both sides of the equation. In this case, we can do log both sides, log both sides. It's totally legit. It doesn't sound legit, but this is totally legit. You can log both sides. It's like you can square both sides, you can square root both sides, you can add 3 to both sides. So why not log both sides, right? So, but in this case, for our convenience, if we log both sides with common log, right? Common log, and then it might be easier because we don't have to worry about like writing base, right? So then remember common. We're doing common log both sides. Common log both sides. So then it's gonna look like log of 5 to the power of x is log of 14 now, right? Then notice we can do the power rule, power property of log in the first one. So now we do this, right? Then it's gonna be x times log, common log of 5 is log of 14. Then in order to isolate x, we can do divide both sides by log of 5. Then cancel, right? So then x becomes common log of 14 over common log of 5. Then by writing this, this is exact value. Then if you use your calculator that you type log t with 14 and division sign and log t with 5, then you can get approximation 1.64. It goes forever, and then you round it, then this is approximation. Then that's how we can evaluate the cases that we can match the base in order to find the values afterwards, right? Then let's utilize this step by step. Then we can make a rule how we can evaluate without going through all the steps. So if you understood the step-by-step approach right here, then when we have log base 5 of 14 and step by step got us log, common log of 14, so which is used to be the value, then log, common log with 5, which used to be the base, right? Then if this is the case, then we can apply every time and we can come up with our rule. So for example, when you're supposed to evaluate number 3, so if you are supposed to evaluate log base 7 of 19, then now you compare the structure here, right? So then now the base is 7 and the 14 will be the value just like 19. Then if we can change this one into common log base, right? This is nothing but log of what? 19 all over log of what? The base 7. Then are we only allowed to use common log only? No. It's up to you to determine the base, right? So you can also do this. If you would like to utilize log base 3, as long as you match the same base with the log top and bottom, and then this is also the same, log base 3 of 19 over log base 3 over 7. This is totally fine too. Then you can do this too. Then log base 7 of 19 over log base 7 of 7. Why not, right? Then this is log base 7 of 19 over 1, which is the original. Right? That doesn't make sense? Yeah. So we can make up the rule here. Change of base formula goes like this. If you have log A of B, then if you are using common log, this is going to be log of B over log of A. Or you can come up with totally not related base, then it can be log base C of B over log base C of A. So now we came up with this change base rule right here. Right here. Then common confusion that I repeatedly observe every year is this. This is different from the quotient. So you always be careful. This change base rule has its own log. Okay. Paul, Louis needs you. Okay. Log base C okay, then this is gonna be log. So either the I'm sorry, I'm confused. What, it's something going on. Okay. So the change of base is log when we have log base A or B, and then it's gonna be changed to the common log. Oh yeah, that's what I was gonna say. So this is common log. And then this is any particular log that purposely that you would like to use, right? So this is just something else. So as long as you match the same log that you are using for top and bottom, and then that's gonna be just the 1, okay? Then, or what if we use the different log here? Can we use log E? Yeah, exactly. So then let me show you a quick example here. And it's gonna be, if I have this, let's use the same. Let's use same example here. So then if I have log base 7 of 19 again, and then if I use the natural log, it's gonna be natural log of 19 over natural log of 7. Easy. And can I use a different one? Yeah, sure. So what if I use log base 5, then it's gonna be log base 5 of 19 and log base 5 of 7. Then the way that you can check is, so, but in this case, you have to calculate each one separately, because this one again will be rewritten as log of 19 over log of 5, right? And then log of 7 over log of 5 again. And then by using the complex fraction, then this is log 19 over log 5 times reciprocal of the bottom, and then log 5 and log 7, right? Then this is cancel, and log 19 over log 7 as well. So that was the original. It just keeps rounding in the circle. Okay. All right.